Hello. All right, here we go. Multiplication of matrices. I'll go through this fairly quickly. Do an example. Here we go. So first we have this idea of scalar scalar product of a matrix, which basically means we can multiply a matrix by a number. So how this works, I'll find. I guess I'll just do this this one here. Okay, so watch this. So 4 times A, I'll write down A is there. So A is this negative 2, 4, 0, 3, plus 5 times B. So this we'll use some addition also of matrices when we're doing this. So first, here we go. So 4 times A is 8. So you take this 4 times a negative 2, and then you get negative 16. That's this 4 times negative 4, 0. And then we get a negative 12. And now I'm going to write down what I get when I take 5 times B. So I get the matrix negative 30, 10, 5 times 4 is 20, and 0. So you see everything is done entry. Each entry is taken care of on its own. Now when we add them together, if I take 8 plus a negative 30, I believe I get a negative 22. That's taking that plus that. And then the next entry, I get a negative 16, 20, and then a negative 12. So that's how you do this sort of scalar product. The idea is that you multiply every entry of the matrix by the number you're multiplying it by. Okay, now let's get to the actual matrix product and see what's going on there. So to do this, we need a definition, and I'll just sort of show you how this goes. I like to think of it this way. Let me just do some examples, then you'll see. Let's try to, I'm going to show you how to multiply these two matrices together. Now, this is I'm just going to put the size of the matrix here. This is a 2 by 2 matrix, right? The first one. And then I'm going to be multiplying it by there are 2 by 1. And it turns out you can multiply these two together. And what I'm going to get a 2 by 1. So you can see matrix. So what you'll see is that sometimes if you can multiply matrices together, you have this nice relationship that the size of the matrix you get out is going to be a 2 by 1. And to be able to multiply them together, you'll see that you'll need that these have to be the same number. Okay, so let me try to do this. So here's how it goes. So if you're taking matrix 2 minus 1, 5, 8, and if I want to multiply that by 3, negative 2, here's what I do. And this may help you to get the correct answer. Over here on the right, I'm going to show you how I think about this. So you have to do this little multiplication thing here. And what I like to do is I like to put the two matrices in this configuration. The one on the right, I put here. The one on the left I put up here, it almost looks like an exponent, but it's not an exponent. But it helps me to realize what I get in here. Because what I'm doing is I'm taking, let's see if you see this, I take 2 times 3 plus a negative 1 times a negative 2. And I do that calculation, and that's the number that will go in the first entry. So that's 6 plus 2, and that's 8. 8. So that's what goes here. Okay. And then similarly, I do a similar type of thing. You see how if you look this way and this way, do you see how it points right at this dot right here? That's how I know how to do the calculations. So I take the 3 times 5 plus, and then we take the okay, so that's this one times this one, and then this one times this one. So I get a negative 2 times 8. And if I do that calculation, I get 15 minus 16, and that's equal to a minus 1. And that, so I put up, that makes that a minus 1. Now when you're writing this down, you would just say that this is equal to 8 minus 1. Now, many people can keep this very straight, and what you're essentially doing, you're taking this 2 times this minus, this 2 times this 3, plus this minus 1 times this minus 2, and that's how you're getting 8. Then you're taking 5 times 3 plus 8 times 2 to get minus 1. Okay, now notice, let's see what happens if we try to multiply them in the other order. So for example, can we find this? Can I multiply 2, negative 2? Can I multiply it by this? Now, let's see what that does. Now notice, in this case, this thing is not defined or does not exist, let's say. We don't do that because notice that this is a 2 by 1 matrix. This is a 2 by 2. And you see, this 1 and this 2 aren't the same. So if I tried this trick over here, I wouldn't be able to do the multiplication. So you can only multiply. The key is if you take an m times n, you can only multiply it by an n times, say, p, and what you get out is an n, an m by p matrix. Okay. Let me do one more here for you so that it makes sense. Let me erase some of this stuff. Okay, let's just get rid of all this stuff, and then you can go back. It's nice with the video. If you miss something, you can just sort of back up and take a look at it here. But let's do one more example here. I'm gonna try to multiply. Let's do this one here. That second one, or the third one, I guess it is. I'll do that one, and you can practice these to make sure you know what you're doing. So I'm gonna try to calculate this and see what happens. So okay, so using my little trick, right? I'm gonna do a little trick on the bottom here, and I'm gonna leave some room to write the answer right here. So let me erase this. So I'm gonna try to find that product. Okay, and remember the trick here that I use is I do this arrangement and I see if I can calculate them. So if I were to take the first one, here's my little trick. So if I take the first one, I line them up, I get 5, 2, 7, 6, 1, 0. And I'm going to try to multiply that by 1, 4, 0, 2, minus 1, 2. And notice, in fact, if you look at here, it really is a nice little rectangle, a little box that you can form in here. And so the answer is, I'll do this one here. I take 5, see how that, if I'm going down this row here, and this column here. So I take 5 plus 4, that's a 9. So you want to go through this and make sure you know where I'm getting these numbers. So to get 9, I take 5 plus 4, because I take 1 times 5 plus 2 times 2, and that's how I get 9. Now let's do the middle one right here, just out of, might as well out of order, right? So to get that one, I take my 4 times 7 plus a negative 1 times 6, and let's see, what is that? I have to really think this through here. 4 times 7 is 28, and then I'm going to be subtracting 6, so I believe I get a 22 right here. Okay, let's see what's in this lower corner. Normally people don't, find the diagonal entries first, but I just want you to see how nice this little trick is, because you can find any ones that you want. Like 0 times 1 plus 0, that's a 0, because you take 0 times 1 plus 2 times 0, well, that's 0. Let's find this one right here. Well, to find this entry, I look in this column and this row, because that points right at that dot. See how that's working? So then I get 4 times 5, that's this one times this one, plus a negative 1 times 2. And what do we get? Oh, I have to think about that. So it's 20 minus 2, I think that's 18. Let's see if I can do this without these little scribbles. I may get them wrong, so make sure I check this. 0 times 5 is 0, plus 2 times 2 is 4, so that's why you get a 4 here. But how about this one? Well, that's 1 times 7 is 7. 7 plus 12 is, let's see, that's 19. 1 times 1 is 1. Oh, that's just a 1 there. That's nice. Notice this is a very good one here. See, if there's a 1, 0, it makes it really easy because then you just repeat because it's 4 times 1 plus, doesn't matter what's here, times 0. And so the answer is, just so that, make sure that you understand what the answer is, if you multiply this matrix times this matrix, you actually get 9, 18, 4, 19, 22. Oops, I didn't fill that one in yet. I'll have to calculate that in a second. And let's see, what's my missing entry here? Okay, my missing entry is if I take this row times this column. So I'm going to get 0 times 7, which is 0, and 2 times 6, which is 12. Right? Did I do that right? Let me double check here. Yeah, very good. And yeah, 12. Okay, so that's how you multiply matrices. I hope that this, let's see what we have here. Oh, let's do one more example here of something. I want to show you how to, here's an example. I'm going to show you how to, okay, let's see what it says. Show that the system of linear equations, blah, can be written in matrix form. Well, let's just take a look at them. And that's why we're doing this, this matrix multiplication, is because we're trying to write down equations that involve matrices rather than, you know, having 2 equations, right, and 3 unknowns. Here we just have 1 equation, right? But the problem is this 1 equation is a little bit more complicated in whole than the 2 equations up here in a different sense. So let's just see how we do that. Well, look at it. I mean, so let's see. Let's suppose that this has a solution, right? Well, if this has a solution, it really does mean the following. You see, if I take this matrix and multiply these two together, what do I get? I get 2, using my trick, x1 plus 3 times x3 plus, I'm sorry, x3, that's an x2 there. Haste makes waste. And the next entry in the matrix, using my multiplication, I take x1 times 1, so that's x1. Take x2 times negative 4, that's a negative 4x2. And then 5 times x3, that's 5x3. And let's see, we want to see is that's equal to 5, 8. Well, we know that the only way that this matrix could be the same as this matrix is if both of the entries are the same, and that's exactly what we have up here in this equation, that both of those entries are the same. So I hope this helps you, and I'll keep doing some videos here for you to help guide you through this, this process.